Hello, good afternoon. Welcome to Mptcp. Just as we're beginning to start, we need some volunteers, please. So we need a volunteer to monitor the Jabber room, to relay questions and stuff. Is anybody able to do that? Thank you very much. Cheers. And we need somebody one or two people to take some notes, please. Who's able to do that? Can you do both? So we probably should have somebody as a backup on the note taking as well. In case your multi-screen abilities break down. Christoph, can you take up some backup notes? Right, thank you very much. So I'm not quite sure how accurate my clock is. I think it's 2 o'clock, so let's make a start. So thank you everybody for coming. I'm welcome to Mptcp here in South America, in Argentina. I'm Philip Eardley. Yoshifumi couldn't make it to this meeting. I'm not sure, is he online up there? I can't read it. Don't think he is he? So welcome to our remote participants as well. I think we've done all of these. Just a reminder, if you come to the mic to make comments, which would be excellent, please remember to say your name. And if the note takers wave at you that they don't know who you are, perhaps you can go and make sure they get your spelling of your name right and things. Here is the note well, as per usual. Great, okay, so here's the agenda I think we've got for today. A quick status on where the working group is from my perspective. An opportunity to hear about implementation news from anybody who wants to share the status of their implementation. I know there's lots of implementation work going on, so it's always really cool to get an update about that. We then have a brief update on the working group draft on experiences, which is about to go to the ISG. We're then going to have a long slot. It may go on longer than that 30 minutes I've got listed there, about the protocol BIS document. So first of all, an update on what's happened recently, and then secondly, a more open-ended discussion. Christoph has some slides to kick that discussion off, but there's a whole lot of things we could discuss under there. We then have kind of 3 slots after that to hear about some things which are not strictly on our charter, but a really interesting work that's going on with multipath TCP. There's some interesting work from the guys at NASA. Rolf Winter's come back with some work that he presented a while back, but it's been updated, so that's interesting to hear about that. And then there's a couple of drafts which Med is going to talk about, so that's really really cool. So any bashing of the agenda? Okay. So a quick update on where we are on our milestones and status. So we've got 3 milestones active at the moment. We've got the use cases and operational experiences, which is just about ready to go to the ISG. I just have to do the Shepherd report for that, and then we'll send it in the next couple of weeks. We've got our update of the protocol document to get it on the standards track, so work is continuing on that. So the milestone's a bit out of date. And we have a milestone on middle boxes. So we we had various discussion a while back, and there's lots of work in the industry on middle boxes which are multipath TCP enabled. We never actually got to having a working group document, so I guess that's something we should think about what to do about that topic. So a note to me that the dates of the milestones need a bit of a refresh, and we agreed last time to remove, managed to successfully remove the milestone about this documenting implementation advice. I have not as yet managed to work out how to remove the text from the charter, so that's down to my lack of inability to use the IETF tools, which I need to go and work out how to do. Okay, so a brief spot now to hear updates about implementations that anybody wants to share. So Nigel down in Swinburne, Nigel Williams, let us know by email on the FreeBSD side where he's got diverted by trying to finish off his thesis, so he hasn't had time to do coding. He's been doing text for his thesis recently, so he will be back on that soon. But any other updates, Christoph?
In Linux, the Intel people have implemented the add-address 2 option. So the new one.
I'm finding it really hard to understand. Can other people hear clearly or not? Is it just me? A bit dodgy. Try.
Hello, hello, hello.
That's worse.
So in Linux, do you hear me now? Yeah. Okay. Okay. So in Linux, the add-address 2 option has been implemented by the Intel people, and they have provided feedback to Alan, which he has incorporated into the new draft, the latest version. And yeah, and so in terms of Linux, we will try to prepare a new stable release. We have released the 0.90 release last time, which was, I think, in September. We are trying to push out the new one, 0.91, for in the coming months or weeks.
So I have not much to report on the Solaris side. We have a working implementation, and we are, the management is going to release it, but for us to release something, it takes a lot of effort to do a lot of performance testing and interoperability testing, and that's what we're going through right now. But if somebody wants a beta, we will be more than happy to provide the bits for them to test it out.
I'm not going to be able to sit here because all I can hear is next door. So I have to move because I can't hear a word that's been said at that mic. Right, this is a difficult experiment. Does that still work? It does, doesn't it? Right, no, I wasn't going to do that bit next. So I think on the agenda next, we were going to talk about the experiences draft very briefly. That's you, isn't it, Christoph?
Yeah, we have updated the draft with the feedback that we got. There wasn't much feedback as far as I remember. So next slide. We added some more information on recent research results. One paper published by the Olivier's team, which provides a framework that allows Android applications to study their interaction with Mptcp. And the second paper, which basically analyzes the data that has been collected through this framework. There's one paragraph that has been added into the document. Next slide. We finalized the conclusion because the conclusion was very short at the time. The conclusion basically says that within the literature that has been published about Mptcp, there were no big issues that have been identified. Some suggestions on how to improve the heuristics like scheduling, path management, and so on. And Sarah, the conclusion also says that there are a bunch of industry implementations of Mptcp that have been successful and has done some widespread deployments. Next slide. There's no more? Okay. So yeah, the draft is at its final stage, and I think we can progress it.
So thanks, yeah. So it completed all the working group stages ages ago. So I now have to write a Shepherd report so it can be sent to our AD, Mia, so it can then be sent to the ISG. So my plan is to do that when I'm back from here.
I have a question. Any of the heuristics have any impact we should put in the BIS draft, do you think?
I think none of the heuristics are concluding yet on like, we don't yet really know what is the absolute best way on scheduling traffic. And I kind of personally think that the BIS draft should not do any kind of decision based on that yet. Maybe other drafts or RFC documents will pop up later, which say if we want low latency, we should schedule that way. If we want high bandwidth, we should schedule that way.
Any more questions or anything? Hey, Ran.
I've not read the draft, and I want to know whether I should read it. Does it talk about data center deployments, for example, high speed disk storage transfers and WAN connections in a data center when you're doing like backups or you're accessing file systems and things like that? In your experience over here, I have not read the draft.
Yeah, sorry, it's difficult to understand. Yeah.
Can you just say your name as well? I don't think you did. Can you say your name for the note taking?
Oh, name, Ralph.
So I mean, if the draft explains any deployments in data centers.
You're talking about the experience. I'm just saying, do you have the experience? Do you have you defined the experience in a data center or with storage? In case of storage, because one of the places that multi-path TCP might be deployed is, for example, backups or through WAN connections when you are accessing multiple data centers.
So from what we know, there's no documentation or any experience in the industry deploying Mptcp inside the data center. Yet there are a bunch of research papers that show what could be the benefit. But in the draft, we don't talk about any industry deployments in data centers.
Any more? Okay. So we're now moving to talk about, in fact, I had a first slide to put up about this. So I'll just have a quick introduction to this. So we're now moving to talk about the protocol BIS. So just to remind people, the primary goal of the working group is to publish a standard strat version of our core protocol spec. We've agreed in the last previously that we will we'll bump the version number. So that means it's not backwards compatible with the experimental RFC. So that decision gives us an opportunity to redesign multipath TCP signaling. We've talked about a number of changes so far compared to the existing RFC. The main one which we've agreed in the past is to make the MP capable signaling reliable. There were a few less significant changes that have already been agreed and included in the BIS, but there's various other changes that are continuing to be discussed, which is really what we're trying to do today. And I wanted finally just to highlight that there's one of these other changes, which is to do with this SYN cookies draft that you can see listed down there, has had an IPR declaration associated with it, which you can go and read at the link. So I wanted to highlight that to make sure people are aware of that and are happy with that statement if we include this SYN cookies technology in the in the new RFC, in the new protocol. So if anybody wants to come and talk to that now, they're very welcome to. But otherwise, I'm just making sure that people are aware of that, because I know different people have different views about IPR.
So we would have to support both implementations, version 0 and version 1, or at some point we're going to say we don't have to support version 0, because for us, if we are coming out with an implementation, we might just come out with one implementation and not two, or not to handle two.
So
because if you change the header, then we would have to do something, right? So it's no big deal, but if you change the signaling, then we'd have to.
This is a draft.
You would have to be, so if and when this document becomes an RFC, then you would have to say, well, we are supporting this RFC, we're not supporting the old one, or we support both. But
Okay.
But they're
Okay.
different protocols, so.
But
yeah.
we don't have a plan of keep supporting this indefinitely, both the version 0 and version 1.
The version 0 exists. It's an experimental document. It exists.
Okay. Okay.
This
got
is
it.
this is a
Thank you.
new protocol now. Yeah.
Okay.
Effectively, that's what we've decided. Yeah. And perhaps this is a question to come back to at the end of the discussion. Is it realistic to get this finished up for Berlin, i.e. to have a sort of working group call, last call around the time of just before Berlin? So we probably should come back to that at the end of the discussion. Alan, sorry, I've stopped in your tracks.
Okay, well, yeah, if you jump on straight away. Just covering a bit more detail of what Phil listed about changes that have occurred. Because we've been able to bump the version number, and this is the important thing to remember, we've now made that decision. We've bumped the version number. We've made some non-backward compatible changes already. We may want to make some more. That's what we're here to discuss a little later. But at the moment, the first backward incompatible change we made is the change to the handshake. The purpose of it, as I said, inspired by the contents of Christoph's SYN cookies draft, we've added some more options in the MP capable that allows us to use it on a data packet as well. So it looks familiar from the top, but there's an extra, potentially an extra 4 octets at the bottom that contains the data level length and a checksum. So these are lifted from the data sequence signal option and means you can basically combine on a first data packet enough information to reassemble the data as you would for a packet that was tagged with data sequence signal, but also carry the keys. The purpose of this is so that we can make the sending of this message reliable. That's really what we're trying to achieve here. Obviously, you can only make an ACK reliable by putting data in it, because then the data is ACK to TCP level. So we've changed things around a little bit as well. The initial MP capable now doesn't carry any keys at all. There's no point. It is just the initial 4-byte header that says I'm multipath capable. That's all that's needed. The SYN-ACK declares B's key, and then the ACK contains A's key and B's key. So at this point, if the server was acting, that B was acting statelessly, it can verify this from the information that's sent back in the ACK. If A has data to send, or indeed, as long as A is the first person to send data on the connection, then we'll also send a message with this option involved, with the data level length and checksum, so that they can use it to reassemble the data, and thus this packet is then acknowledged, and we know it's been arrived reliably. I've said a large chunk of that. It's also worth pointing out that if B has data to send first, then you know whether the ACK was reliably delivered there, because it will include a data sequence signal option if it was. This is only in the case where A has data to send first, and it will include those additional fields. Anyway, that's a recap. We discussed this in Yokohama. It was received, agreed on the list, and now it's part of the protocol. As I said, because this is now version 1 of the protocol, we have information in the draft about how to do fallback, or how to negotiate different capabilities should you choose to implement both, although we don't expect many people would choose to implement both versions. And also it means we can save on our option space and free up that add ADRA to add ADRA 2 option space that we no longer needed, and renumbered it back again because it doesn't need to be compatible anymore. Got a few clarifications as well on 64-bit and 32-bit sequence number space after our lively discussions about this. We've clarified a few things about generating HMACs, and the experimental option where we previously just reserved it for internal use of some description is now formalized as per Olivier's draft there. And that's really all that was changed in 05, although it's relatively significant in terms of the version number change. In terms of a diff, it's actually quite small on the document because it's just a change to the handshake and a few clarifications. As Phil said, what we're now really asking and opening to the floor is what else is it we may wish to include in V1 of the spec, as it were. So Christoph has a discussion on front-end proxies, which we can start after this slide set, but what else might we want to do? And we have a question at Mike.
Question with Mark from Microsoft. Yeah, there is something that I would like to see personally in the document. It's a discussion of the privacy effects of Mptcp and the privacy protections. As it is possible for someone to listen to the initial exchange, get a copy of the keys, and then by listening to other exchange on other links, discover that this other exchange belong to the same source. I mean, they have to do some work. I mean, the fact that you use a hash means that they have to do some work there. It's definitely possible to find that new connection belongs to the same set of multipath TCP connection as the other ones. And that has the effect that if you are moving around on the network, by using multipath TCP that way, you disclose that you are the same party that was at some other location before. So It's clearly a trade-off, but that trade-off should be discussed in the security session.
That kind of stems back to the original design spec of multipath TCP. I accept the point, but in many ways, the endpoint has to have something there that identifies it as being part of a connection. That is our initial, whenever you add a subflow, it's got to know what connection it belongs to. So in a handshake, we've always assumed this information would always be available.
I'm definitely not suggesting that you change the design.
Yep.
I'm suggesting that you document the issue.
That's okay. Yeah, we can certainly make a mention of that. I mean, it's part of the design as well to permit edge proxies and networks being able to correlate flows like this. It's been part of the design and use cases of the protocol from the start, because we have vendors of edge devices that want to be able to do this kind of correlation, because it needs to know if they've gone from Wi-Fi to wireless, Wi-Fi to wired in a network.
And that it's probably perfectly fine for many users to allow that correlation.
But there's privacy concerns, I understand. We'll make a mention in a privacy section. I think that seems a good choice.
Thank you.
Mia Kulevin, I just had a great, or maybe not so great idea, I don't know yet. In TCP Inc., we decided to not encrypt the header, but we could potentially encrypt some of the options. So maybe that solves the problem, because I mean the Mptcp option doesn't need to be visible to the path, only to the endpoints. But that's something that would need to be brought to the TCP Inc. working group.
Yep, that's a good point as well. We can certainly mention that.
Yeah.
Yeah.
Somebody, if you comes to the meeting and mention it.
Well, there's no other points, then Christoph, I guess.
Any more? Christoph?
Yep. Okay. Next slide. So, as Alan mentioned, in the latest version of the BIS document, we have updated the handshake to allow sync cookies, which, as Alan already explained, is that the SYN segment only contains an Mptcp payload option that is of 4 bytes. So, next slide. So, which means only 4 bytes. That means we gained a lot of space here, basically 8 bytes. And we are thinking that we could use them to address some of the remaining issues of Mptcp that we already discussed at the past meetings with respect to load balancers. Next slide. So the 4-byte Mptcp option means we have plenty of new space. From the previous meeting, we have been saying that we should separate the token from the key. As has been mentioned, the token is the hash of the key, and by having a hash, the token is basically, let's say, non-deterministic, and so the token doesn't provide any information for load balancers and so on. And so by separating the token from the key, we can make the token have a meaning to load balancers, because the server decides what token he's going to use, and so he can decide the token in such a way that it makes sense to the load balancers. Additionally, by separating the token from the key, we can make the token generation much simpler, because we can easily make sure that the token is locally unique on the server side. And so from last meeting, it was said that, yeah, we should separate the token from the key in order to address those kind of issues. Next slide. So if we then, some maybe design ideas that we might throw around until the next IETF so that we can maybe finalize the BIS version. We could, for example, specify the token explicitly inside the handshake. By doing this, basically, the SYN includes the token A, and the SYN includes the token decided by the server, and in the third act, we echo everything again to support stateless servers. The problem with this approach is that we don't have any more space options to include the keys, because we still need the keys. Next slide. So we have, as I mentioned, we have no more space for the key. Now, however, the key could come from something out of band, meaning, for example, we could derive it from TLS, master secret, or whichever other key negotiation mechanism is running on top of TCP. We could derive it from TCP crypt, we could derive it from some other crypto protocol. But then we still need a fallback in case the application layer protocol is not negotiating a key. So next slide. So one idea with this, with the additional option space that we have now, is that the client could announce inside the SYN the supported key selection algorithms that it allows. And so the server decides then which one it is going to use. So if this client is using TLS, he says, okay, I allow deriving the key from TLS, but I also allow, for example, the legacy option in case the server is not compatible. And so that way we can fall back to the legacy handshake. Next slide. So just as an example, let's say the client wants to use TLS and the legacy one, but the server doesn't support it or doesn't want to use it. The server then simply replies falls back to the regular handshake that we have in the current version of the BIS draft. And then we can continue and go on. Next slide. However, if the server correctly supports the TLS derivation mechanism, then, well, he will just confirm it inside the SYNAC and just exchange tokens with the clients. And then the keys are being exchanged through an out-of-band mechanism, TLS or whichever other mechanism. This would mean that we just need to define for every of those application layer protocols or key selection algorithms how those keys are being negotiated between the two, between the client and the server. And then the keys are being exchanged, and also they are being secure. Attackers can no more hijack Mptcp sessions by eavesdropping on the initial handshake. And yeah, it would allow to address several of the issues that we have with load balancers, security, and token generation. And we would like to push something along those lines forward for the next, until the next meeting, and get this into the BIS version.
So in your description, you talk about applications. One of the things with multipath TCP is we've talked about is applications could not be changed. So you mean by applications, you mean the two kernels at the two ends, because the application is not running, it's not going to be running in a vacuum. It's going to be running it with some kernel, and so which means that each application will not. Right now, we don't have the API for each application to even tell the kernel what it wants, so the kernel can really not change.
I think this kind of, if we use, for example, a derivative of the TLS key, this means that the application becomes Mptcp aware. And that's why we also still need the legacy fallback for those applications that do not support this API.
No, I don't have a problem with what you're saying. Fallback is great. What I'm saying is each application, it will not be able to decide what it wants because it's the kernel, unless you have the API for the application to tell the kernel, I want this particular connection to be in this way.
Yeah. Yes, we need an API that allows the application to tell this to the TCP stack. Yes.
So, any comments? Is everybody happy with this? We include this approach? But we basically have please.
My name is Dennis. Maybe that sounds like a bit stupid question, but could you in a couple of sentences explain why the encryption function should belong to the transport layer? Why not leave it to the layer that uses the Mptcp connection?
Sorry, I don't understand your question. Can you maybe repeat the...
I mean, what is the sense of doing the um, doing the what is the sense of trying to protect the exchange at this layer instead of leaving this function to, for instance, a library that uses these transports to actually transmit data forth and back?
You mean why would we leave the key exchange to the higher layer? Or
Yes, like it's done in Mptcp. In TCP section, there is a means for transporting data forth and back, and then on top of TCP, you can have a library that would actually try to authenticate or encrypt data or interpret or present it in any other way that is required.
I might misunderstand you, but I think what we are trying to do is to indeed hand over the exchange to the higher layer, because TLS and technologies like this can make sure that the key doesn't go through in clear text, while in current Mptcp the key is being exchanged in clear text. If I'm not, maybe we can discuss this later. I'm not sure whether I understood your question.
Okay, thank you.
Alan Ford, so just to be clear then, at this point there's absolutely no connection at all, right, between the token and the keys? No connection at all between the tokens and the keys, potentially?
Yes.
In the legacy fallback, would the token then be discarded, the token A you included, if the far end didn't support it, and thus we send another one?
In the legacy fallback, there would then be the need
For a new
to
token?
have this link, yeah. The legacy is legacy, yes.
I think this will work. I think this will work quite well, because it's not breaking any functionality we had in the original Mptcp, because we've still got the fallback here, and the extensibility options of this are quite large, actually. I mean, we're only talking about TLS here, but we could be using it with all sorts of authentication.
Yes.
If a user wants to, we need a registry for algorithms or something in MPCapable. People could write drafts that add it, with an experimental thing. It's like another sub-protocol there, but it'll work. Yeah, I can't immediately see of any issues with this as an approach.
Okay. We'll try to, for the next meeting, get something more, a draft or something readable, so that we can progress.
The sooner the better, I would hope.
Yes. Okay. Next week? Yeah. No. Okay. Next month.
Well, if we could write up what's presented here, this is a bit of a departure from the previous version of the draft, I feel. Or if it's not, it didn't come across that way. So we
You mean the TLS draft?
So we document this, and then I think we've got a good discussion point.
Yeah. Yes.
From the Jabber Room, there is a concern about whether or not we should go to a new version number already, and also about opportunistic encryption, and we should have end-to-end encryption on top of anything to secure routing or TCP subflows.
Yeah.
Sure. I guess the first one would be there's concern about whether or not there should be a new version number at this point.
A new option number?
I think there was someone had said version number up here before, so maybe they misinterpreted. A new version on a protocol number.
That's correct. So we did have some working group discussion on the list and in the meeting, the last meeting, about increasing the version number, and there was consensus to do that. So if that person is unhappy with that, they need to raise that on the list and see if they have support to unwind the decision that we made. You know, if there's a new argument or whatever to come up with. I mean, I think we understood at the time that it has some drawbacks, but if they have some arguments why we should reopen that decision, that's fine. But I think that'll have to be done on the list. I don't think we can have it over Jabber.
Okay, and then I think that was mostly at the concern about the version numbers right now.
There were some other things that you said about
Yeah,
opportunistic encryption or something, was that?
Oh, let me see here. And I'll have to ask if any, I'll ask them to elaborate on what their concerns are on encryption and bring it back to the mic.
I'm Julius Krobacek. Am I overstepping my bounds if I carry over something that's going on Jabber? Oh, yeah. If I clarify this. So there is one comment that I found interesting, which says, seems like such a major change should be at least tested experimentally first. I missed it. Has the new handshake been studied in any tests? Unquote.
Sorry, whether the handshake's been tested. Yeah.
Or it might have been a comment about the,
Well, there were two comments in there, weren't
might have
there?
been a comment about the 05 handshake, but that's why it's published. This is a draft. We decided in the working group this is the way we wanted to go. Feedback welcome. If there's concerns about its practicality, then please raise it on the list.
It would probably be good if we have the multiple implementations, trying it out, do interoperability and so on.
Absolutely.
Probably with Linux, we can do something, I don't know, with...
So perhaps I can rephrase how I heard the question, or that there were two. One was about the fact that we now have a new protocol number, new version number. Should that mean that the output is experimental track rather than standards track? I think that's something we will need to think about the chairs with our AD. And the second question was, as I interpreted it, was whether there was practical experience of this new handshake procedure. So has it been implemented, and do we have some testing of how well it works?
From my side, I don't know of any implementation. No, not yet. I think at the moment in the BIS draft, from what I know, only the new add address option has been implemented. All the other things like the reset, the experimental option, none of those implementations are currently available.
Right, so the new the reliable signaling of MP capable has been implemented? No, just the add address stuff. Okay.
No. Only the add address option has been implemented from what I know.
So do you know if you guys or Olivier have plans to, the Linux guys have plans to do some implementation soon?
I don't know if Olivier will have, Olivier's team has the resources and time. From our side,
Olivier, I can see you're on remotely, so if you feel like trying to, I'm not sure if you're in a mode where you can speak or you can only listen, but we could try and use this Meet Echo if you are able to talk. He's probably not. Sorry, Christoph, I cut you off.
we can, from our side, we'll probably, in the long term, definitely implement a reliable MP capable option. Whether we will be able to do this for Berlin or not, I cannot commit to it because, well, yeah, we'll have to see.
So is there any more discussion on this particular point about signaling? Oh, there's more on the Jabber room.
Yes, sorry for overstepping my bounds again. Julius
thank you, Julian.
Krobacek, and I'm quoting Olivier Bonaventure, who is saying no plan at UCL for the moment on that. Maybe experimental draft, maybe experimental option will be implemented, but not handshake.
Alan Ford, I think it's worth just pointing out that this discussion, this use of it with TLS and so on, is outside the scope of the protocol. The only protocol changes that this proposal would imply is the negotiation of something else to use for the key and token generation. That's the only effect on the wire protocol from the BIS draft point of view, and thus allowing people to write other experimental drafts about how to use it with TLS, for example. This is not proposing adding using it with TLS into the BIS draft. This is just providing the framework in the BIS draft to allow extensibility with other key negotiation mechanisms.
I would think that the modifications to the protocol are not that major in this case here. Yeah.
So I think this is something that is worth people thinking about, discussing on the list, and let's get an impression in the near future of whether people are happy with this, to include this or not. People want to react further here now, that's good, but I think it's probably people haven't really had time to think about it. There hasn't been a draft or anything, so I think it's not reasonable to ask for a hum whether people like the idea or not. So I think people need to have a bit more time to think about it before. Couldn't expect people to give a reaction that a reaction to it. So are there any other things to add that are in progress, or you're expecting somebody's expecting to propose or bring in, or do we think this is kind of it for the changes that we are likely to include in the BIS document? That's a question for you and for the room.
From my side, we are good that way. We could of course do for the version 2. We can do all kind of fun things, like address the privacy issues that Christian brought up. But okay.
I must say that Christian, I must say that this idea of exchanging the key out of is encouraging, because I mean there's a potential to also deal with the token that way, and then actually solve the privacy issue. That'll be really nice.
Yeah, that's a really good point. Yeah, if the application layer protocol allows to exchange something like a token, I don't know if there's something in TLS that we could abuse kind of as a token. But okay, that's
there is a method in TLS to export key material from the master key. There is a, you cannot quote it outright, but you can find an RFC to derive another secret from the TLS master secret.
Yes.
And then you could use that technically
as a token,
and use an IO control of some kind to put that in the connection context.
But I think in that case, this would imply that the token is still non-predictable, which is crucial for the load balancers to support the Mptcp. We need to be able to generate a token in such a way that the load balancer can steer the traffic in the right direction to the right backend server. But okay, that
Maybe we should
this.
discuss that offline,
Yes.
but it has solution.
Yeah.
There are solutions to that too.
Yeah, that seems interesting.
So that sounded really interesting and would be excellent if that could be followed up. Yeah. So yeah, Christoph, if you can write a proposal in a draft, at least an outline one as soon as possible,
Yes.
that would be excellent, and then we can at least make sure that the working group's happy for this general approach, and then you can do another version with you know, more of the detail in
Yeah.
it, but to have at least an initial first version quickly, so we can make sure that people are happy with going this way, would be fantastic.
Okay.
Just as a note, when we do this, we should split it into the draft into impact on this and not impact on this. Maybe even two drafts, I don't know, or at least split so it's just clear what, if it was selected to be included in the BIS draft, what would come out of the BIS draft and what would stay in the separate draft on it.
Okay. Okay. Let's discuss later about this. Yeah.
Any more on this, or any more on things that people believe should be added to the BIS document? New functionality that we think we need to put effort into fixing. Okay, I think that's excellent. Thank you, Christoph. Where's the blue sheet, please? Could somebody raise it? And could you stick your hands up if you haven't signed it yet? Right, so there's one here and quite a few on that side. I only put one out because we only had about 15 people when we started. There's a few more now.
So how much can you put in the new BIS? Because one of the things that we find interesting is the ability to encapsulate other protocols. Like there is a draft out there which says we can put UDP within multipath TCP and use multiple endpoints. I don't know whether we've discussed this as a group or not, but that sounds very interesting. And actually, I've looked at it because of a problem that we have with the product group to use multipath TCP to do it.
So I don't know what other people's reaction is. I mean, I guess my feeling is that probably that would be something separate rather than in the protocol. But I certainly agree. It sounds like it's an interesting use of it.
But it depends on what you call a minor change. So let's have a discussion on the draft. I don't know even if the group wants to do that or not. So I don't think we have had a discussion on whether we would allow other protocols to be encapsulated. The advantage of doing that is if you can use UDP, then you have multiple paths, plus you also get reliability because of TCP, and that's one motivation that we are trying to do with the product.
Will advance it might be a little premature since the talk on like options is coming up, I think, after this, but we're interested in the UDP option of multicast TCP also.
this is perhaps a dangerous question to ask. Are other people, perhaps you raise your hand if you're interested in this area of having encapsulation of other things like UDP in multipath TCP. There's at least 2 people who've said they're interested in doing that. And there are quite a few hands. There's probably about, for the notes, probably about 8 people who've shown interest in doing that. So I think that's something that we should think about talking about rechartering to include that, or thinking about how we should do that.
Rolf Winter, so there's been work on hybrid access, and some people are interested in running traffic over an Mptcp tunnel.
So, Julius
Yes, so-
Krawczyk.
Go on.
So speaking about UDP stuff, if you're doing UDP most of the time, it's because you need more flexibility than for the transport layer is giving you. And perhaps it should be considered whether this shouldn't happen higher up the stack, like at the application layer. I'd like in particular to attract your attention to some work that has been done by Mathieu Boutier in Paris about doing Mptcp stuff, like stuff within Mosh, which is an application that runs over UDP, entirely in user space, entirely in the application.
Yeah, I mean, people have experimented doing it at all sorts of layers, haven't they? Like the RTP layer and things. So, I mean, I think that's why we certainly have to think carefully about whether we did it as a work item, because you're kind of saying we think this is the right way to do it if we did it here. But I think it needs a longer discussion about that, whether it's a potential topic we should do. But yeah, I agree with you. You can do it at different layers. And just to follow up on Rolf's point, we were both at a barb-off, I guess you call it, last night, talking about hybrid access, which means trying to combine DSL and LTE to give people improved access at home, typically. And there are a whole variety of technologies that people have looked at, have got working systems using different ways of bonding together those 2 paths. And some of those people have used multipath TCP in some form, including with tunneling of other traffic. So that's certainly something that people have shown a real interest in. Brian.
I just wanted to say hi, Brian Trammell. I just wanted to say congratulations for being one of the first working groups. I've heard people in a long time talk about encapsulating UDP in something as opposed to something in UDP. I mean, we should just stack all of these things. So we've done a little bit of work in this space, and so we were just sort of debating about the work that needs to be done. Obviously, it is very easy to run in, if you do this blindly, it's very easy to run into the competing congestion control algorithms problem if your UDP traffic is actually something that's encapsulated on top of UDP that, like if you wanted to run quick over Mptcp like this, you'd have to be relatively careful to make sure that the things that got sucked into the tunnel were the right things to suck into the tunnel. These are things that you can do from configuration. Operationally, you can like say, should not, must not, but which is, I put my hand up because it's like, yes, this is interesting and we should be able to do it. And then I put my hand halfway down because it's really easy to get wrong.
Any more on the discussion of this topic, or any more thoughts that people have on things they want to see in the protocol? Okay, cool. So we will, I think we'll continue to have a target of being pretty stable for Berlin. So we'll have Christoph producing something in the next month, and we'll see if the working group's happy with that approach, and then go ahead with adding the details. and we'll have some sort of chair and AD discussion about how we want to, if we want to look at rechartering to do some of the other tunneling stuff we've just been talking about. Now for something completely different.
So, good afternoon. I'm Will Ivancic. I'm with NASA in Cleveland, Ohio. My colleague sitting back here is going to complete the second half of this short briefing. So, we're using multipath TCP at the other end of the spectrum. NASA flies a lot of atmosphere research aircraft. And as you see, this is a Global Hawk. The nose of that thing has a KU band satellite antenna in it, but when they fly like over the poles, the North Pole or South Pole, or sometimes in the middle of even on the equator, they don't have KU band satellite coverage, and they use Iridium phones and mux them together to get 4 phones to get 9.6 kilobits per second. So, well, everybody else is trying to get gigabits per second, and so what they do right now is we use multi-link PPP, so point-to-point protocol. It's been around for quite a while to mux these things. And it works, but it doesn't work really well because when the aircraft turns and there's shadowing and things, you get dropouts. And what happens in the implementation of multi-link PPP that they use, there's an option to do no fragmentation. It's in the kernel, they don't use that. And so if you lose anything on any one of the channels, you lose everything. So generally what they do is they really restrict the type of traffic you send over it and make it very small packets so that it sort of alleviates this problem. Next slides. I'm going to skip over most of these again and again. That's all. One more, and one more. So this problem is you have 4 channels, and if you lose a channel and you're fragmenting, you really lose a lot of stuff. And we believe that multipath TCP can help you here because you really aren't fragmenting anymore. And if you lose a channel, it will figure it out and bring you back into compliance. So we've just started getting test beds together and getting these things up and running. And so we have a little bit of results here, but we'll have much better things later on. But a lot of it has to do with queue management and things like that because your back off timers really start backing off and your window size is like 1, things like that. Next slide, please. You know how multipath TCP works, so I won't tell this group that. Go ahead, one more. And so here's the idea for TCP. Channel 2 goes away, multipath TCP will figure it out. We don't have the problem, and the reason we want to use multipath UDP in the same thing is because people are sending UDP traffic over this, and we think we'll get the same benefit in UDP that we would get multipath TCP. And that's our motivation for why we would like to also run UDP over it. Next. So the idea is, this is some engineering hardware. It's not really the flight stuff. The flight stuff's much more compact. But the idea is to not have to change any hardware. You just change the software. It makes things very nice, quick, easy to do, and useful. One more. So there's 2 ways that the system can work right now. One is your aircraft would be on the left with 4 modems. It comes into a ground station at Hawaii, actually, and then they run plain old telephone service, and we have modems on the other side. So 4 modems on the aircraft, 4 modems on a ground station. interesting thing that we were just talking to people is that it's not so easy to get plain old telephone service anymore. So, so it's hard to actually run these modems anymore. So there's also a motivation potentially the next documents we talk about you know, proxies and that, and moving some of this stuff into the actual ground station. There's actually potential to do that. Next. So, and this is the other one to do, is just modem to modem, and we have this set up in the at Glenn Research Center also. Next slide, please. This is actually how Iridium ground station works in Hawaii. So our aircraft is on the left there with the four phones, 4 modems. It comes in a ground station and it sends it out. You can either send it out on 4 plain old telephone service lines and we run the modems there, or you can actually ask them to terminate at the ground station. We generally don't do that right now. But you could and conceivably put multipath TCP in the service right in the ground station. Next, please. So this is our engineering test bed. The indoor unit, you can sort of see 4 modems stacked up across, and we have 2 servers on the bottom. So one acts as the aircraft, one acts as the ground station, and then we have 2 sets of antennas. You can see these plates up here, and you can see them over there. So they're each one is 4 antennas, which is goes to 4 modems. So one of these units acts as the aircraft, and the other unit acts as the ground site. You can see from looking at, say, on the top left picture, that it's pretty much clear sky there. All those modems should see the same atmospheric perturbations and things like that. So from that, I'll turn this over to my colleague Matt Sargent, who's been running some tests, and you'll see some interesting things, especially regarding the modems, and then you go, oh, that's why things don't work so well and why you need something better.
Thanks, Will. Next slide, please. So what you're looking at here are, we've started to collect signal strength from our Iridium modem setup in our engineering test bed over about the last month or so. And you can think of signal strength like being the bars on your cell phone. It gives you a value, each modem will give you a value between 0 and 5. 5 is the best. 0 means you have no connectivity at all. We've translated that into various colors, which I guess they're kind of hard to see here, but the idea here is that green is good, right? Green means you have connectivity, red means you have no connectivity. And as Will was saying, you would expect that all these antennas are about in the same location, they have the same view of the sky, you'd expect them all to be up or down at the same time, but that is not the case. And sort of when this problem was brought to us, we sort of didn't believe the people that said that they were experiencing this. We said, oh, you guys are crazy. But now that we've had our own test bed set up, we see this is in fact the case. And so something like multipath TCP could be nice because, for example, on the left there, that's the status of 4 different modems. So those top 2 modem lines are mostly green. So we should be able to use those all day long. Whereas something like modem 2 is rather spotty coverage. So it goes away for minutes, it comes back for a few minutes, and it would be really nice to use that when it's up, and then when it goes away to get rid of it in a timely manner. Right now with multi-link point-to-point, it could take minutes, depending on how you have it configured, before the link even realizes it's gone. So once you lose one link, you're not just losing all of your packets for a short period of time, you could have minutes, and then usually people are killing applications and doing all sorts of stuff as an end user if they're trying to actively make use of TCP over these flows. That just makes the problem even worse. On the right here, occasionally we do have to deal with all the modems going down at once, and nothing's really going to help us there. If you don't have connectivity, you don't have connectivity. But really we care more about the left case here, where we could easily bring these links up and down in a timely manner. Next slide, please. So over the Iridium modems yet, we haven't set it up to run multipath TCP. But we do have another test bed here on the right. Kind of ignore the text for now. I'm going to talk through some of this over the next few slides. But what the right should show, from this angle, it looks like a mess of wires and networking equipment, and I assure you it very much is. But what it allows us to do is it allows us to take 2 end hosts and connect them together over 4 separate paths. So we have 4 IP addresses on either end for each end host. Each one of those IPs can only traverse a single path across our test bed to one interface on the other side. So what we're running right now is the full mesh path manager, but really, even though we have 4 IPs on either side, only 4 subflows are ever successfully established. The others just sort of are unable to make it. So initially we were running version Mptcp version 0.87 because it was sort of what we were able to install on the hardware we had. More recently, we have newer computers that can run the newer versions, and as of like a week and a half ago, we got Mptcp 0.90 up and running, and we're able to mess around with some of the coupled congestion control. So next slide, please. So each one of those paths, we limit to 2.4 kilobits per second to sort of mimic the Iridium modems. But as we're still collecting sequence strength from the Iridium modems, we don't know how often losses are going to happen. So we want to sort of model that behavior first and then plug that in to our research test bed so that we can more accurately mimic the loss conditions we're going to see in production. So what you're looking at here are time sequence graphs. The squares up there and the vertical segments are each color-coded based on subflow. So the vertical segments are packets being sent, the squares are acknowledgements being sent back from the receiver. The solid green line tracks the largest cumulative ACK we've seen so far. And sort of the question that we want to try to answer is how much can Mptcp serve as a sort of a plug-and-play solution for us? What are the minimum number of changes we can make and get this easily deployed? Because we want to use this in production, and it seems like some folks are scared about making a bunch of changes. So if we could plug this in easily, suggest a few configuration parameters for them, then they can get it up and running, hopefully using it on various aircraft. So as you might guess, just sort of plugging in something like Cubic, running it across all 4 links, keeping your initial congestion window large, doesn't work all that well when you only have 2.4 kilobits per second. Right? Cubic isn't designed for these slow links. So you get situations where you blast out a bunch of packets, but then those take so long to get across the links, your RTO grows. If you lose something, we have idle time of about a minute there, where even though we have 4 subflows, presumably 3 of them are good, the Mptcp implementation does nothing until the RTO kicks in and then data is retransmitted. Next slide, please. So even if you do something, if you continue to use Cubic and say, oh, well, let's make our initial window smaller, you run into the same problem. Here there's no loss, but you experience the same sort of ramp up where every time you get an ACK back, you're kicking up 2 new segments, and that's really easy to overwhelm our links since they are so slow. Next slide, please. Additionally, Cubic sort of was behaving in an unexpected way. At first, when I was looking through some of our packet traces, I thought that we had high loss on our on the path that our ACK acknowledgements were taking across our test bed, which I thought was strange. But then sort of taking a closer look at our packet traces, I realized that after you send enough data, so if you make your flows longer and push more data across the link, Cubic starts to enter a state here where the receiver actually stops sending ACKs back, almost like a delayed ACK, but instead of being acknowledged immediately or milliseconds later, it's multiple packets later, so you can have 10, 15, 20 seconds of no feedback coming back from the receiver, which just seems harmful to something like multipath TCP that wants feedback so it can make better decisions about where to steer packets. And this was, at first we thought maybe it was linked to a certain kernel or Mptcp version, so we tested this across various kernels, Mptcp implementations, even architectures, just to make sure that this behavior could be seen all over the place, and it was.
Christoph Bosch. There was a fix by Samsung done recently for something like this, where the receiver stops sending ACKs because the window is not growing anymore, and so he thinks there's no need to provide feedback. If you use the latest 0.90, like really the latest, of the Mptcp trunk, you should probably rerun those measurements and see if you are still observing this.
Thank you. Yeah, I'll grab it. We can update our machine when we get back. Yeah, that'll be nice to see. Actually, it was just sort of an unexpected behavior, and at first we were checking everything else first to make sure there wasn't something we were doing, and it just kept on coming up all over the place. Thanks. Next slide, please. So as of somewhat recently, we started to experiment with version 0.90 and some of the coupled congestion control, and just in a nutshell, it's working much, much better than Cubic. It prevents you from ramping up too quickly. Sort of over time, it figures out, hey, your links are very slow, I'm not going to push out that much data. It makes relatively good use of spacing out the data across the links. And even when we're missing a packet there, you can see where the ACK line sort of flatlines out for a while. You are getting constant feedback. and data is continuing to be sent. So you don't really, we haven't really seen as many idle periods pop up yet running tests. Now we also haven't started to try to mimic the Iridium channels and inject a bunch of loss. So we still have to see how that'll perform in the future, but just sort of an initial finding on clean links, it seems like coupled congestion control is going to bias quite a bit, especially when compared with something like MLPPP. And then one final slide, please. And then just, even when you are using coupled congestion control and it takes it a while for it to ramp up, after you send enough data, then it starts to get a little bit braver and starts to kick out packets a little bit faster than it should. Which means that you do have some spurious retransmissions because you're timing out before you should based on what's been happening previously in the connection, but eventually it does sort of self-correct and you end up in a state where every so often you might have a spurious retransmission, but it doesn't continue to ramp up like cubic where your RTTs and RTOs just keep growing and growing and growing. So going forward, hopefully in the near future, we'll be running Mptcp over Iridium on our test bed, and we'll have enough data to see how our links compare to the production links and what they think their view of Iridium satellites are versus what our view of Iridium is. And then we'll be able to see if, hopefully, in a month or two, if we could push Mptcp into some of the test aircraft, into the production environments to see how it's actually going to work when they're up in the sky flying around the poles, banking, and so on. Thank you.
Thank you. That's really interesting. Any questions? Okay. It's you, Rob.
I think it's kind of unthankful having the presentation after somebody talked about Iridium phones and drones and ground stations on Hawaii. It's probably going to be very boring, sorry about that. So next slide. I'm going to talk about multi-path support for single home end host. So you might have seen this in 2011 because what we did at the time, we specified a bunch of DHCP options, so 2 DHCP options, and we implemented it and we tested it, but then MIF came along and they said we are working on something that will solve your problem, and that's provisioning domains. And they have been working on it, and they have 2 specs for DHCP v6 and for neighbor discovery, and so we thought now it's the time to come back to look at it and whether it actually does the trick, and it nearly does the trick. And this draft basically adds a little bit to it, so we can do the same thing that we proposed in 2011, but now with provisioning domains. Next slide. So the problem we're trying to solve is that multi-path TCP runs on end hosts that are at least dual home, so they need 2 interfaces or more. But for the foreseeable future, there's going to be a lot of end hosts that are single homed. So think of office PCs or even devices at home, or even if you have a multi-home device, you might want to save energy and not have all interfaces up all the time. So we believe that if you really want to make use of multi-path TCP, these are environments where it would be good to actually do it. So end hosts that are single homed. And while a lot of devices will be single homed, the access is going to be multi-homed increasingly. So like we were at this BOF yesterday, at this bar BOF, and there's a product in Germany out there, it's called Hybrid Access, and you get a home gateway, it has an LTE interface, and it has a DSL interface, and there you have multi-homing. So it comes really close to the regular customer already. It's not just campus networks, it comes really, really close to the customer. So the big question is, can we somehow make those multiple paths available to the end hosts that are single homed? And we believe we can. Next slide. So that is one of the scenarios. Think about it this way. You have a home that sits on a LAN, you have a gateway router that is connected to 2 ISPs, and you have some auto-configuration mechanism. It doesn't have to look like this, but this is roughly the scenario we were thinking about. And it doesn't have to be DHCP, there's neighbor discovery and things like that, right? But take this as an example. Next slide. So there's a couple of desirable properties we think a solution that addresses this. So somehow making multiple interfaces available that are not directly attached to the end host. One is there should be no changes to the Mptcp protocol. So no behavioral changes and no changes to the wire format of the protocol. It shouldn't be too complex. So if you have a box somewhere that has to implement multi-part TCP or certain logic or has to keep a lot of state, we didn't really want to go down that path because it will, it will create certain failure scenarios that are hard to debug, it causes a lot of overhead on the box. So it has to be a high-performance box. But we didn't want to do that because, especially for the home, these boxes are cheap, they are low power, and we don't want to change that really. And we didn't want to introduce a new signal protocol. So we don't want to have another protocol that's signaling something to a middle box and then it can do something magic. We didn't want to do that either. So it should be really simple. Next slide. So the key idea is really simple. And what we did in 2011, we actually implemented and it works. It's not that difficult to actually do that. So in 2011, it was all, so the software available at the time, it was all configuration and one little script, and it worked. Well, on Linux, it worked very, very easily. So the key idea is you create virtual interfaces, and most operating systems today allow you to do that. So you have a virtual interface, and the number of virtual interfaces on a host correspond to the number of real interfaces that the gateway has. And you basically, you configure those virtual interfaces with different IP addresses. So for the Mptcp stack, it looks like having real multiple interfaces, and it will just use them, although they're really virtual. You will use a shared link in the home or in the office, but they are usually very high bandwidth, and then the gateway is going to make sure that every multi-part TCP flow is going to run over a different external ISP access network or something. Next slide. So here's an example. You have the host, so both have to be multi-part TCP capable, but it's stock multi-part TCP. You have a gateway router somewhere, and that is multi-homed. So in this case, it's again our ISP1 and ISP2. And the draft basically describes how the end host is going to realize that there are multiple provisioning domains, and it defines an option so that you can request an interface being configured in a way that the gateway makes sure that the packets from this interface, in this case one of those two interfaces is virtual, is going to exit through one ISP, and the other packets from the other interface are going to exit to the other ISP. So basically, on the host, it looks like this virtual interface is going through ISP1, and the second interface is going through ISP2, although there's a shared link in the home or in the office or on the campus. And the way we do this is we configure the gateway, so you'll get the virtual interface and the physical interface will get an IP address configured out of different prefixes, and the gateway, based on the source IP address, is going to load balance across those two links. So multi-part TCP is just going to work. It doesn't realize that one of them is virtual, but here's going to be load balancing. And based on the loss on any of these paths, Mptcp is going to do the right thing. Next slide. Right, this is basically how it's going to look like. So the blue flow is going to go through ISP1, and everything that comes from the interface is going to go through ISP1, just as if it would really be attached to that ISP, but it's not. Yeah, next slide. Okay, so currently in the draft, the only thing we did was the DHCP side of it. We have a new option called xroute. And based on that, in the provisioning domain, the DHCP v6 server can basically signal if you configure an interface based on this provisioning domain, it's going to go this way. And if there's another xroute option in another provisioning domain, the end host will know that the packets from that interface will going to go through a different access network. Next slide. There's an alternative, and we have played a little bit with this alternative, and this is you could in principle use ECMP on the gateway. You need a little bit of entropy for this because it's going to work on the 5-tuple. And what you could do is you could basically, the Mptcp stack could generate different source port numbers, and it will have potentially enough entropy. But this is try and error. It's not very exact. You don't know how many external paths you have. So you might have shared bottlenecks and things like that. It doesn't matter because Mptcp on shared bottlenecks plays nicely, but it's a heuristic basically. Next slide. Okay, so for the next version of the draft, we want to add the neighbor discovery part of things. We want to expand the text a little bit to describe the host behavior a little bit better. It's a bit vague in places, but we're going to do that. We're going to muse a little bit more about potential other deployment scenarios, and we are going to implement and test this new version of it. This is going to be a bit more work because we have to actually now touch the server and do a little bit of coding instead of configuring and a bash script. But we're working on implementation of this as well. And that's it.
Julius Krobacek. I don't know if you're familiar with the home networking group where we have been doing something very similar. So HomeNet is mostly interested in IPv6. So what happens is that we have a network with potentially multiple gateways to different ISPs, which each assigns a prefix to the network, and hosts get assigned multiple addresses. So that's the equivalent of your virtual interfaces, one for each ISP. And the network, and that just happens with no host changes, just by sending router advertisements with multiple autocount prefixes, or DHCPv6, however you want to solve it. And then what happens is that the data is being routed using source-specific routing to the right gateway. There are no needs to any changes to DHCP. There are no needs to any changes to router advertisement. And so HomeNet is chartered to require no host changes. So that's a really badly kept secret that we're actually testing with Mptcp.
Okay, so can you point me to a document? Can you point me to a document?
HomeNet architectures.
It's in the architecture?
Yeah.
Okay. So, but wait, how is it working? So you have a single interface so you bind that all to the single interface, multiple IP addresses.
We have multiple addresses on a single interface, and Mptcp works with that out of the box.
It does. So
yeah.
It does.
Yeah.
It's
really good.
Okay. Okay, interesting. All right. Oh, I have to look that up and actually test it. Okay. Okay. Right. But this is neighbor discovery specific. It is only working with neighbor discovery. This is specific to neighbor discovery. Doesn't DHCP mandate that you can only use a single offer?
So in our tests, we've been using router advertisements. I don't want to say something stupid about DHCP.
Right.
I'd rather avoid the subject
okay.
of DHCP.
Okay.
Any more comments? Nope, thanks. So Med, you're up.
So thank you. Yeah. So I'm very pleased to present this draft on behalf of my co-authors. So this is just a simple option, a simple Mptcp option that we want to introduce and to specify. So in the next slide, please. Yeah, the next one. Next one. Yeah, so just as a reminder, yeah, our main target is a service provider-oriented requirement that we have. We want to aggregate the resources that are associated with various network attachments that are associated with a given CPE, and we want to increase the capacity and to enhance the quality of experience of our customers. The problem is that we don't control the servers, we don't control the terminals. The only thing that we control is that the CPE that we are managing, that we are offering to our customers. And we also control the network because this is our business. So given the constraint that we have, so we are planning to introduce specific features into the CPE itself and to enable sub-dedicated functions in the network side, which is called the concentrator. So the concentrator here, I'm just presenting one single instance, but this is something which is functional. That means that you can have multiple instances of this concentrator on the network side. And one key important aspect that we have is that we are controlling both network attachment. That means that we are controlling both the radio, and we are also controlling the fixed line. We are not planning to use network attachment that are belonging to other service providers. So this is very important because we are controlling the configuration of the middle boxes that may be in the path, especially for the mobile attachment. So the next slide, please. So even if you are a proponent of Mptcp and if you have to collaborate with the others, so when you go to your one of your favorite vendors, there are various arguments that they give to you if you are asking to have Mptcp as an implementation. The first way is that they tell you, anyway, your concentrator is not in the first hop. You need anyway a tunnel. So I have already a solution for you that already does the service bounding at the tunnel level. You don't need Mptcp for that. And the other argument, which is very, very noisy for us, is that Mptcp is only specific for TCP. And we want something which is generic, which applies to various protocols. There are UDP, there are the increase of other applications that are currently using UDP, and they are using other transport protocols. So Mptcp will solve a portion of the problem. You will need another solution to solve the other piece of problem. So it does not work for you. So just as an example, I'm just showing here an excerpt of a document that is edited by another organization. I know it's not very, I would say, diplomatic to say that other standardization are releasing some documents that include some comments, but the problem is that, yeah, that excerpt, what I'm interested in is only the part about UDP. There are something which is there very old, and you as an Mptcp group, I think that you have to socialize what Mptcp is doing in practice, because there are something which people, yeah, misunderstood about the specification itself. But so, especially for these use cases, what we because of these reasons, we have edited this document, this specification, to solve this problem. That means that we want something which applies not only for TCP, but for any protocol without requiring any encapsulation, without requiring any tunneling between my CPE and the network side. The next slide, please. So how we do that? We do that with a simple option, one single option. This single option is that it includes various specific information that will be used at both the CPE side or also at the concentrator in order to instantiate the state. There is one specific flag there, which is the D flag bit, which indicates the direction whether the information that is enclosed in the option itself, it is the source or the destination IP address. We have this dedicated field which indicates the protocol that we are just cloning the protocol field which is carried in the IP packet itself. So it will tell you whether this is a TCP, UDP, DCCP, SSTP, or whatever protocol that you are carrying inside your Mptcp connection. And then you have an IP or IPv4 address and optionally a port number. So in the next slide, I will show an example of how we can use this option. This is the example of a deployment that you don't have a requirement to preserve the same IP address of the source. That means that at the concentrator level, which is the customer internet-facing interface, you can share the same IP address between various subscribers. So in that case, what we are doing is that when this outgoing SYN packet is going out, it will be intercepted by your CPE. The CPE will dispatch this flows among various subflows that are established between your CPE and your concentrator. But there is no tunnel, so the destination IP address will be replaced by one of the IP addresses of your concentrator. But inside the SYN packet, there will be this option, which is the plain mode option. So the D flag will be set to 0, and this option will carry the ultimate IP destination address. So once that packet will arrive at the concentrator level, it will extract the plain mode option. So this will know what will be the destination IP address. It will replace the destination IP address with this one. But the source IP address will be chosen from the pool that has been configured to the concentrator itself. So this is a basic netting operation with some TCP. Yes, Araf?
How is that not a tunnel? It's a new tunneling technology.
There's no tunnel at all.
It's a new tunneling technology. You just put the IP address somewhere else. It's not IP and IP, but it's IP in a multi-part TCP option. How is that not a tunneling type technology? It's not an existing one, it's a new one, but it's
I will explain later that this is only done at the SYN level, but the following the subsequent segments, this option is not present at all. It is only at the SYN level. But anyway, you can call that a tunnel if you will right now, but this is not a tunnel. Okay, so this is for the outgoing packet without address preservation. Next slide, please. This is an example of the incoming packet. If there's an incoming packet, and if you want to that the concentrator aggregate multiple accesses, so yeah, the destination, the source IP address will be included in this plain mode option with the D flag set to 1. And the same operation will be reiterated at the CPE to retrieve the source IP address. So it will be replaced at that, by the CPE itself. So the packet will be sent to the destination host, which is located behind the CPE. The next slide, please. Now, if you want to preserve the same source IP address, and this is something which is very, very important for IPv6, all the solutions that I am aware of today, and including GRE tunnels or mobile IP inside which you can use Mptcp, etc., they don't preserve the same IP address. They require an IPv6 function, which is an IPv6 for writing prefix even at the CPE side or at the concentrator, which is very harmful for applications in which you are carrying IP addresses. So if you have IP addresses applications that are using referrals, they will be break if you are using the IPv6 function. We are not using that. We are preserving the same IP address at the egress interface of the concentrator. So this is to do that, we are injecting two instances of the plain mode option. The first one will include the source IP address, and the second one will include the destination IP address. And just when the packet will arrive at the concentrator, it will reuse this information to build the outgoing packet. So the source packet that will be sent at the egress interface of your concentrator will be the same IP address as the host behind the DCP itself. Yes?
I'm thoroughly confused. Can we slow down a second? What packets does a plain mode option exist on?
Sorry?
A plain mode is on every packet, is it?
I didn't get that.
The plain mode option is on every packet, every Mptcp packet.
Your option, or new option?
Yes.
Is it on every packet or only on the SYN?
If you wait until the next slide, you will see where there's the option.
I will save all my other comments then.
Okay.
You saving yourself, Rob, or do you want to?
So how can it not be on every single packet? Because if the ultimate destination has to be reached, it has to be on every single packet. Otherwise, the concentrator doesn't know where to send the packet to, right?
Yeah.
So it has to be in every single packet. Otherwise, it doesn't work. But is there enough room to actually carry those options?
Yes, one part of the answer is that there is a state that is maintained by the CP itself and the concentrator in order to glue the packet with the state that is maintained in the concentrator for the write-in operation. So
Maybe one thing you might clarify is, for every connection that is created by the client, how many Mptcp connections are created between the CPE and the concentrator?
It depends on the number of the network attachment that you have, and also whether this connection it would be elected to be aggregated or not.
So if the client creates 10 TCP connections that are eligible for this bonding,
yes,
there's only one Mptcp connection.
No, there will be as many Mptcp connections as your TCP connections. This is not specific to this option in any way.
So I think the people are being confused by the concentrator. You can remove the concentrator and I just have two hosts, and the UDP packet will still end up in the same. So remove the concentrator and assume that in the TCP, in the multi-path TCP packets, you are sending UDP packets. And all they're doing is doing an address translation at the concentrator. That's all they're doing.
There is not always an address translation at the...
Right. So for example, in our case, we won't want the address translation. So we will add the D flag there saying this is the right destination.
Exactly.
In your case, you're not adding it. So
exactly.
That's all that.
Exactly.
So, but the question, maybe you can cover later as to how do you do with fragmentation.
Yeah, this is a valid question.
But that means, so the concentrator, I assume, will concentrate many customers.
Yes.
Then it needs a lot of file descriptors to keep. I mean,
I have troubles. Yeah.
I know, because the speaker space here and there, you're behind the speakers basically. So it basically means the number of Mptcp connections at the concentrator is equal to the number of TCP connections that the host is opening. Is that right?
Yeah, it will be a function of the TCP connection that are. Yeah, so it will be a function of the TCP connection that are eligible to be to the bonding services. Not each TCP option that is initiated by a host will be eligible to the bonding service. There is a logic somewhere in the CP or the concentrator itself, so we will decide whether we have to aggregate or not. So if this TCP option is elected to the service, yeah, there will be an Mptcp connection for this one, yes.
But there's a lot of connection state on the concentrator then, potentially.
There will be as many state as Mptcp connection. This is just the normal way of function of a proxy or a CGN.
But they don't terminate TCP connections. That's the difference. A TCP connection is a lot more state, a lot more logic, a lot more processing.
They will terminate because otherwise they can terminate, but it depends if you want to track the TCP connection or not. But we have the same scenario for the CGN itself. We have two implementation, whether you track your TCP connection or you don't track your TCP connection. This is the implementation specific for me, and this is outside the scope of this document. Okay, so yeah, just to present where we put the payment option. Okay.
Me and because I'm still not completely clear on the scenario we have. So even if you would have a UDP connection, you would send the UDP traffic to the proxy, would strip the UDP header, put it into TCP, and then send it to the other end, and then strip again the TCP header, and then put the UDP on, and then send it to the final destination, right?
For UDP, yeah.
Okay.
You're just talking about this next slide.
But I mean, like, okay. I'm not okay, but like, people use UDP on a purpose, right? If you just strip the UDP and make TCP out of it, that's not always the right thing to do, I guess. But yeah, fine. But I understand the scenario now. Thanks.
Yeah. So Yes, so this is the example of UDP. So if there's a UDP datagram that is received at the CPU side and which is selected to build in service, so this will be there will be a swapping, header swapping. That means that the UDP header will be replaced by a TCP header, and inside the packet there will be display mode option that will indicate that the protocol is 17, which is UDP. And then when this packet will be received by the concentrator itself, it will detect that this is a UDP packet, and then it will do what the necessary operation so that a UDP packet will be generated at the egress interface of the concentrator itself. And you can do the same job for other protocols. So this is just how it works. So to the question where we put this option, we have two alternate approations. Either you will go for something which is stateless. That means that in every packet segment that you will send to your concentrator, you include this option. This is an overhead. This is stateless, but there is an overhead. And the feedback that we received from some implementers is that this is very complex to do. So the option that we are recommending for that is that we include the plain mode option only during the connection establishment. That means that in the SYN packet. And in the SYN packet, we put it in if there is enough space left in the dedicated option space. Otherwise, we put it in the payload itself. This is very important because because we are controlling both access networks, we are sure that if there is a firewall somewhere there, it will not reject a SYN packet that include data. So these are all the issues that we may have at the using this kind of options at the internet level doesn't apply in our context because we are controlling both network accesses. So and all the interference with the middle boxes doesn't apply in our context. And one additional comment here that I'd like to make here is that if, for instance, you are supporting the out-of-band packet in order to increase the option space, you can do that, and we don't preclude it, but we don't require it either. So that's why we are not mentioning that option here. So just to summarize, we put it in the SYN packet, we put it in the option, if dedicated option space if there is enough space. Otherwise, we put it in the payload of the SYN packet itself. Now, for the question, I don't know if this answer to your question.
Actually, I have a question is, because we can put it either in the option space or in the payload, what is the trade-off between one or the other?
There is an order.
No, but why would I ever want to put it in the TCP option space if I can also put it in the payload? Because that way I preserve some option space.
Yeah, but if there's, I am talking about the CPE itself or the concentrator. If the concentrator receives a TCP packet, the TCP packet already carries a set of options there. So either I inject my new option in the dedicated space if there's enough space. Otherwise, I will put it in the payload. Yes.
I'm Hendricks from Nokia. The reason why we put it in the option space is if you do TLS and stuff like that, if you put it in the payload, you have to decrypt. And so we are not really, we are a middle box as a proxy, but we are not, if you put it in the payload and it's encrypted, you don't have access to it.
So when there's not enough option space, then, and I want to do TLS.
So we need option space here, right? I agree, but given you are a proxy, you can probably leverage that, right?
Exactly.
So because you're actually, this thing can only have so many options depending on the proxy you're performing. So, but putting it in the payload, if you do encryption, it's even worse, I think.
Yeah.
Right. So if
I think only you and Mirja really have understood this because I still haven't. Is the reason why you need to have a separate Mptcp connection per eligible flow, whatever that means, because you only want to put it in the SYN? Because otherwise you could have it in the...
Exactly.
And then you were cheating us before because we have two options and you already gave us one. Because the decision here put it in the SYN only and then maintain state, because then you need the 5 tuple to match this against your state. That's the reason why.
Yeah.
Now I understand it, and it feels wrong.
With Hendrik from Nokia again, I think we still need state because on your downstream traffic, you still need to map your flow to the outside back to the inside. So you need somehow, you can probably remove the state for the different packets, but you need to maintain some state for the downstream traffic to map it properly again. So I don't think you save a lot by putting it in every packet.
It seems strange to me that you would put it, you won't put it in a SYN, then you add it in a packet, which means that I could send packets. I can multiplex packets, some packets without this option that would have to be treated differently, and something with this option would have to be treated differently on the same connections. That just seems a little strange to me. And how does the your concentrator know that there is in the payload there is this option? Do you is it in the option space as a TCP option, or is it going to be a multipath TCP option? How do you know that there's going to be this extra option in the payload if it's not in the SYN?
This is a good question, but again, this is not specific to this. The decision, if I got your question well, is the decision to elect a TCP connection to be
right. So I could send a payload which does not have this option, and I could send a payload which has this option, which just seems strange to me that you're being able to send 2 different kind of payloads on the same connection, because you know, I didn't send the option on the SYN.
That just wouldn't work because of segmentation and reassembly along the route. You lose the packet boundaries essentially.
No, but what he's saying is whether you want to do this interpretation of the packet. If I don't send that, then it will just think that is a multipath TCP packet without the clear option, and it would be treated as just as a simple multipath TCP option on the same connection.
Do you have an example of what the payload looks like here? Do you have, is there any other UDP header or TCP header information that's in the payload as well? Underneath. Yes. Do you have any other? Yeah, please.
The payload is exactly the same, so we don't change anything on.
Okay, so you've got no indication of the UDP fragmentation over there. You haven't got an idea of the length of the UDP packet when you reassemble them.
Yeah, this is one of the issues that we want to discuss.
Oh, okay.
Yeah, that's a very good one. So so this is just for the UDP to explain the alternate approaches that we have investigated, that there are 2 options there, because when you will swap your UDP packet to be included in a TCP formatted option packet, there is this the RTT delay that can be problematic. So either you pre-establish your connection, your Mptcp subflows before to anticipate that there is a UDP packet that arrives, and then you inject it in the existing connection. But this requires that you send during the establishment of the connection a plain mode option with a null IP address. You don't know what will be the IP address, so it will be null. So once you have the information, that you have to inject your new plain mode option with the exact IP address. This will be very complex. And or we have the other one is that we initialize, we include the UDP payload itself in the payload of the SYN packet that we during the SYN establishment. So there is just a swapping of the headers that applies both at the CP itself, at the concentrator. By doing so, we are because the difference between the UDP header and the TCP header, there's a risk of fragmentation. So what we are recommending, a first recommendation is that to increase the MTU at least with the difference between the 2. But this is just deployment specific again, and there are some specific operations that are up to the implementation, whether if you want to enable or disable reordering, or if you want to some TCP-specific function. If you don't want to have these features for UDP flows, you can just disable them at the CPU or at the concentrator. We don't mandate any list of functions that should be disabled or enabled. It's up to each implementation to decide about this. So this is the issue that you mentioned. So for the time being, what we have just indicated in the draft that there is just one-to-one mapping between the UDP datagram and the TCP datagram. That in case of fragmentation, we have to consider other alternate options in the specification itself. There is also this decision whether we need to include multiple datagrams inside the same TCP segment. If we want to do that, how to do it, whether to include the langed field or not, and so on. So yes?
I'll answer this very quickly. Issue 2, yes, because UDP packets, they're datagrams. It's not a stream.
Yeah.
So you can't just map it like you're talking about mapping it. They're datagrams. You've got to map them as datagrams somehow. So you have a tunneling protocol around this. You can't just map it.
And this is what I struggle with when I did that, is how do you boundaries, and also the overhead of, for example, if the same packet goes out on multiple TCP links, and there is some other packet injected, also how do you keep the order? So
that makes sense. Yes, Ralph?
So you introduce a lot of new stuff, new options. You need to keep a lot of state, and you need to strip headers and put headers back on. I don't see the benefit of just having an Mptcp tunnel there, where you don't have to do anything. The only thing you lose is a little bit of MTU, because you have an additional IP header and an Mptcp header.
Are you talking about UDP?
No, in general. I mean, why not
UDP?
just having a tunnel? It doesn't even have to be multi-parties. You can use GRE or something else, but
because it doesn't work.
Why does it not work?
Because if you have a tunnel between the CP and the concentrator, you don't have any indication that the flows that are injected in the two tunnels belong to the same UDP. I would say the UDP flow. You have extra information. You need to inject extra information at the encapsulation level, so that you glue all the datagrams that you will send in this packet, so that once received at the concentrator, it will decide that it belongs to the same stream.
Why does it need to know that? It doesn't need to know that.
Because
this original IP address is still in there. It just sends them out.
It's the last answer.
Wim Hendricks, Nokia again. So why do you need to put extra header in the tunnel? Is because you need to so you send a packet of a given flow to two links, right? So you need to reorder. So you need to know that the packets belong to the same, flow, and as such you need to reorder the packets. And as such, that's why we need to add extra information into the tunnels in order to achieve these things.
Okay, this is what we heard yesterday, right? It's the GRE keys. Okay, but
plus you need to invent flow control and stuff like that on top of the tunnel to be able to achieve the back pressure and stuff like that.
So I'm going to interrupt. Sorry. We have less than 1 minute left of the meeting. So something you may not want to answer now, but have you brought this just for information and for interest for the group, or do you come with some greater request than that? Okay. We couldn't adopt it at the moment because it's not it wouldn't fall, in my reading, part of the work that we're chartered to do.
Just a comment about that, because what we are...
And since we have about 10 seconds left, so I think if you want it to be work that the group does, come and explain or send an email with some, a paragraph or two of the rationale,
why you think the work needs to be done, point to the draft, and we obviously would need a lot more discussion around it because people are kind of unclear about lots of aspects of it. But we have now finished, so thank you very much. It was a very interesting discussion. Thank you particularly to the note takers. I hope you enjoyed taking notes for that discussion. I expect a full and in-depth line-by-line report, and I'll be very cross, Will, if you haven't managed it. So, Mia, do you want to say something?
Yes, because this is about tunneling, so probably a broader audience, speaking of the TSV working group, would be nice. So you can just send it to the TSV working group as well. Announce that this document exists on the TSV working group list.
Okay, but this is not tunnel, but
You'll get further eyes on the idea. Thank you very much to everybody for coming. If you haven't seen the blue sheet, it's up the front. Please come and find it. See you all in Berlin. Thank you very much for a lively meeting. Bye-bye.